So section 2.1, we're going to review some things from algebra, which is going to translate or transition rather into some things we're going to learn in geometry. In algebra, you studied functions. You learned how to solve for variables using function notation. So let's look at a few examples of those. So example 1, what's the value of this function, f of x equals 2x squared plus x when x equals 4? Just a reminder that f of x is the same as y. Those are identical things. So to show your work properly for this is work that you're required to do. You're going to first write down the function as it was given. Then we are to substitute a 4 in for all the x values. When you substitute the 4 in, every place you substitute it in, you are required to use parentheses. Sometimes the parentheses will change how the problem is calculated, and sometimes it won't. We're going to always write it so that we'll always do it correctly. Order of operations, we do exponents first. 4 squared means 4 times 4, which is 16. I eliminated the parentheses here at this point because they do not affect the problem. Continuing order of operations, 2 times 16 is 32. Then we add the 4 to it and we get 36. So the function evaluated at 4 is 36. Please note that I left this and this blank. If you want to write f of 4 in those blanks, you can. It is assumed that anytime you leave something blank, that whatever's there is whatever was above it in the line previously. You do have to write it here at the end, though. So the answer to this problem is, if you put a 4 into the function, you're going to get a 36 out. That's one example. Let's check out another. What's the value of the function f of x equals negative 5x plus 1 when x equals 11? We're going to write the function out first. Sorry about that. Did something wrong, and I got a message that popped up and didn't read it. Not much of a reader, more of a skimmer myself. Then we're going to substitute 11 in for each of the x values. So f of 11 is going to be negative 55 plus 1. Therefore, f of 11 is negative 54. So we put an 11 in, we got a negative 54 out. Just to compare real quick, the work between those two problems, the only difference in my work is that I showed these f of 11s, and here I didn't show the f of 4s. You can do it either way. Third example. What's the value of the function when x is 5? So we write the function out first. Now I'm going to replace all the x's with a 5. When I do so, I use parentheses. Looking at this fraction, this is a negative 2 divided by 5, then I'm multiplying it by 5. We are dividing by 5 and we are multiplying by 5. 5 divided by 5 is 1. So that leaves us with f of 5 is negative 2. I wrote that down wrong. F of 5 is negative 2. So our ordered pair for this, put a 5 in, we got a negative 2 out. Once again, this is review from Algebra 1. Hopefully, this is all coming back to you. So as it says in all these words here, in the problems that we just did, we were given an x value. We had to find the y value. Well, there's going to be times where you're given a y value and you have to find an x value. Just want to remind you again that f of x is the same thing as y. This is saying y is negative 29. So we write down the function, just like we did for the first 3 examples. We're going to replace f of x with negative 29, because we're told in the problem that's what it's equal to. If you do a substitution, like we just did here, And the substitution covers the entire side of the equation, like the negative 29 did. You don't need to use parentheses. If you choose to, that's cool, but you don't have to. Trying to get x by itself, we're currently subtracting 5 on the right side of the equation, so we're going to add 5 to both sides. Negative 29 plus 5 is negative 24. 8x minus 5 plus 5, 5's cancel. We just get 8x. To get x by itself completely, we're going to divide both sides by 8. Negative 24 divided by 8 is negative 3. 8x divided by 8 is x. Therefore, the x value is negative 3. To write our answer, we're going to write when x is negative 3, y is negative 29. Number 5. Same kind of question. What's the value of x when f of x equals x cubed minus 14 and y is 13? So we're going to put a 13 in for f of x. Trying to get x by itself, we're going to add 14 to both sides. So we get 27 is x cubed. To get x by itself, I have to cube root both sides of the equation. Cubed root means what number times itself again gives you that answer. The cubed root of x cubed is x, because x times x times x equals x cubed. What's a cubed root of 27? Let's say you're not good at cubes. That's cool. Pick a number like 1. What's 1 times 1 times 1? That's 1. It's not 27. 2 times 2 is 4, times 2 is 8. That's not 27. Let's try 3. 3 times 3 is 9, times 3 is 27. So the cubed root of 27 is 3. So we put a 3 in, we get a 13 out of this function. That's an ordered pair. Number 6. What's the value of x when f of x is 1x over 3, or we could have just written that as x over 3, when f of x is negative 15. Trying to get x by itself, right now we're dividing by 3. Opposite of dividing is multiplying. Going to multiply both sides by 3. What you see in there in blue is optional work. If you choose not to show what's in blue, you will not lose credit. So we get 3 times negative 15 is negative 45. On the right, the 3's cancel. I'm just going to rewrite this to make sure it's clear. This is a negative 15, not a subtract 15. So our ordered pair for this, we put a negative 45 in, we get a negative 15 out. So there's 6 examples, 3 of which are given x, you need to find y. 3 of which you're given y, you have to find x. So what does this have to do with geometry? Well, it has everything to do with it, quite frankly. Instead of us calling these functions in geometry, although what we just did were functions, there's a different way to do it, and that's called using inputs and outputs, preimages and images. What you put into the function is called the preimage. What you get out is called the image. So in this case, what was an x is going to become an x plus 3. So if your x value was a 7, you add 3 to it, it's now a 10. The y value was a y, now it's a y minus 6. So if your y value was 10, you subtract 6 from it, now it's going to be 4. A different way to write that is this here. The coordinate rule T maps all points x, y to x plus 3, y minus 6. So you have a point out in space, an ordered pair. It's going to go to the right 3, and it's going to go down 6. So, just a little bit more reading here. To help clarify the difference between preimage and an image, we use a special notation. If the preimage is point A, then its image will be A prime. Prime notation means it's something new, it's an image. Well, let's get to an example. Hopefully you're going to see some similarities between this and what you did in algebra with functions. Given coordinate role m, xy, becomes 3x minus 1, 5y. Determine the image of 3, 2. So here's what we need to know. This x value that you see here is an x value, obviously. This 3x minus 1 is actually x prime. That's the new x version. This y value is in the preimage, and this 5y is actually y prime. Here's how you're going to show the work for this. You're going to make an equation with x prime being equal to 3x minus 1. 3x minus 1 comes from the image. You're going to make a separate equation for y prime, and that's equal to the y value of the image. Then, if you look at the question, it says determine the image. You're supposed to find the image. That means that this right here is the preimage. The preimage is the x and y value. So let me just make sure that we are completely, well, it says it right here. Preimage is x and y, and the image is this. So I'm going to replace the x value with 3. I'm going to replace the y value with 2. That's going to give me an image, x prime and y prime. So x prime is going to be 3 times 3. That 3 is coming from the question. That's the point A is 3, 2. 3 times 3 is 9. 9 minus 1 is 8. Let's say that you can do this in your head. You can go directly from this to this. Congratulations, you're amazing. You still have to write all this work. Y prime equals 5y. The y value of the preimage was a 2. 5 times 3 is 10. Therefore, to sum up, point A had coordinates 3, 2. Using this coordinate rule, A prime is now going to be 8, 10. Simply put, to make this abundantly clear, we put 3 times 3 is 9, minus 1 is 8. We took 5 times 2 and got 10. Preimage to image. Let's check out another one. This is point W. Pardon me, it's rule W. We have point B. Rule W says whatever your x value was, subtract 4 from it. Whatever your y value was, multiply it by negative 3. So this is going to be x prime, this is y prime. So x prime is going to equal x minus 4. Y prime is going to be negative 3y. Take the ordered pairs that we were given up here in the instructions. Plug in negative 1 for x. So x prime is going to be negative 1 minus 4. Let me color code this for your viewing pleasure. Negative 1 minus 4 is a negative 5. For y prime, we're going to replace the y value with a negative 2. Let me color code that for your viewing pleasure. Negative 3 times negative 2 is 6. So to sum up, we had this ordered pair for B. It was negative 1, negative 2. We used this coordinate rule, W, and by using it, we transformed this into B prime, who has coordinates negative 5, 6. Long story longer, we took a negative 1 and subtract 4 from it and got negative 5. Took a negative 2 and multiplied it by negative 3 and we got 6. Just like when we started out on the previous page, we were given x values and we found y values. In that case, x was the input, y was the output. For these problems, there already is an x and a y. The original ordered pair is the input. We just calculated for 7 and 8 the outputs, the image. So for 9 and 10, we're going to be given the output, the image, and we have to go backwards to find the input or the preimage. Set this up the same way. If you choose to set it up the same way, and that's what you're going to choose because I'm not giving you a choice, you're going to find this to be really easy. We have coordinate rule T, which says the x value is going to become 5x plus 3. The y value is going to become 7y. So, it's written down here. We are going to say that this is x prime and this is y prime. So we're going to write down the equation just like we did on the other examples. X prime is equal to 5x plus 3. Y prime is equal to 7y. Now how this is different, we are given the image, the output. The output is 13 and negative 7. This is x prime and y prime. So when we substitute into our equations, we have to put that in the proper place. X prime is 13. Solving the equation for x, we're going to subtract 3 from both sides. We're going to divide both sides by 5, and we get x is 2. X being the preimage, the input. So where we would have started before using this transformational rule. Y prime, we have is negative 7. If you divide both sides by 7, you get y is negative 1. To sum up, give myself a little bit more room here. If we were to start with the ordered pair 2, negative 1, we would end up with C prime, which is 13, negative 7. Once you're finished, if you want to check your work, it's pretty easy to check your work. If I take a negative 2 and put it in here, it's going to be 5 times negative 2 is 10. Pardon me, it's positive 2. 5 times 2 is 10, and plus 3 is 13. That's what C prime is. If I put negative 1 in here, 7 times negative 1 is negative 7. That's what y prime is. So it checks out. Shall we do another? I think we shall. I'm going to write down that x prime is x plus 7, and that y prime is 2y over 3. Look carefully. We're supposed to find the preimage. That's the original x and y value. We are given the image, which is x prime and y prime. So x prime gets replaced with negative 4. Y prime gets replaced with 4. Solving each of those, simple algebra. Hopefully you remember how to do this from Algebra 1. And the equation has x in it. I'm going to subtract 7 from both sides. An equation with y in it. Lots of different ways to solve equations. I typically like to get rid of my fractions right away. What I'm going to write here in blue is optional. You don't have to show this. I'm currently dividing by 3, so I'm going to multiply both sides by 3. It's going to give me 12 equals 2y. And if I divide both sides by 2, I get y is 6. So we're supposed to determine the preimage. Well, the preimage is going to be D. It has coordinates 11, 6. Just showing you the full gamut of what's happening here. That becomes D prime, which we were given up here, with the ordered pair negative 4, 4. Almost finished. Just another way to look at this input-output process, whether it be a function or a coordinate rule, is that there's this function machine. You put something in, some stuff happens, and then something comes out. This particular function machine, the stuff that's happening is that whatever x value you put in, you're going to always add 5 to it. So let's look at using that rule. The directions say, use function machine above to determine the missing output or input values. You are going to write the function down every time in its original form if you want full credit. You then look at what's given. This is the input. Input goes into the x values. So it's going to be f of -4 equals -4 plus 5. When you substitute, use parentheses. Therefore, f of -4 is 1. The output is 1. If you wanted to go a little crazier, sometimes I go a little crazy, you could write the ordered pair, -4, 1, input, output. Answering the question, though, you just have to say output is 1. Looking at this next example, number 12. First, write down the original function. You must do this if you want full credit, and you will learn quickly that I do not bluff, unless I'm playing cards. Bluff all the time. The output is -1. That is the y value. If you were talking about a coordinate rule, that would be the image, whereas the preimage is the input. We put -1 in for y. Solving the equation for x, we subtract 5 from both sides. We get the input was -6. If you wanted to go a little bit overboard and say it's the ordered pair, -6, -1. It's not required to do that for this problem. We just have to say what the input is. 13, write down the function f of x equals x plus 5. Examine what we're given. We are given the input. The input goes in for the x values. When you substitute, please use parentheses. 2.5 plus 5 is 7.5. Thank you so much for your attention. We just completed section 2.1. Your assignment is GCO.A2, Practice Worksheet 1. It's in the homework section of your binder. Thank you very much.